In the United States and many other places around the world, grading for elementary, grammar schools, colleges, and universities often employ letter grades, with the subtle gradations being they often put a plus or a minus. Whereas in some other places in the world, France, for example, uses a point scale with 20 being the amount for each course, probably so it easily adds up to 100 if you take 5 courses. Be that as it may, we still use number equivalents for the computation of the GPA, often associating the A with the 4 and so on down. Notice we do skip the E, with an F getting a 0. And as just about any student knows, some professors, and some do not, use a curve, a distribution for the final course grade, where if there's not enough or too many of a particular grade, they'll shift it so that it looks like what's called a bell curve or a normal distribution, in perhaps an effort to be fair, reflecting perhaps maybe the temperament of their grading, or perhaps maybe the difference between classes, or maybe the difference between professors in terms of their severity or leniency thereof. And whether that's fair or unfair certainly depends, A, upon somebody's viewpoint, and B, their competence. And of course here we have the stereotypical relationship of the bang-covered, I'm not going to complete this rhyme, of the professor or teacher and the backward baseball-capped student, who each one are thinking, gee, I got ripped off, or gee, boy, was this a bonus they didn't deserve. And of course, maybe the very process of trying to be fair is in of itself unfair. What do I mean? Say what? Yes. Here's a distribution, both from a uniform as well as a normal distribution of some 27 students, and it's across, say, 10,000 simulations, make it a confidence bound of 0.01, and that's pretty good. And what it says is that, you know what, look at this. You can have 1, 2, 3, 4, 5, 6 different points of difference between semesters or courses or professors if you had distributed them just by the laws of statistics. And that 6-point difference is almost 2, maybe 3 grades. There's something wrong here. And for those of you so inclined, or is it reclined, here is the computer program. Did it in BASIC, a little easier than Excel, for those of you who don't realize that Excel has a lot of limitations, including its normal properties. And, well, the previous one was uniform. Here is the normal distribution. You got the equation there for a normal distribution, and it created this previous chart. But wait, there's more. Look, here is different runs with 100 students, or 12 students, a large class and a small class. Somebody will probably remember something called the central limit theorem. And sure enough, larger the class size, smaller the dispersion, and vice versa. You know what the upshot is? Small classes are more likely to be treated inappropriately, unfairly, hurting or helping poor and good students if you grade on the curve. That critique is less strong, less severe, less of a concern if it's, let's say, with a large class. Then that grading on the curve perhaps is less judgmental. Something to think about. And by the way, for those of you so inclined, here are the programs I did for each of those.